rectifier introduction. Many electronic circuits use DC voltage for operation. We can easily convert AC voltage or current into DC voltage or current by using a device known as PN junction diode. PN junction diode allows electric current to flow in forward bias condition and blocks the current in reverse bias condition. Simply, a diode allows electric current to flow in one direction only. This unique property of diode allows it to act as a rectifier. So what is a rectifier? A rectifier is an electronic device that converts alternating current into a direct current by using one or more PN junction diode. A diode behaves as a one-way value that allows current to flow in a single in a single direction. This process is known as rectifier. A rectifier can take the shape of several physical forms such as solid-state diode, vacuum tube diode, silicon control rectifier, and various other silicon-based semiconductors. So rectifier are mainly classified into types of rectifier: uncontrolled rectifier. Bridge rectifier are many types and basic for the classification can be many to name a few types of circuit. Bridge circuit configuration, controlling capacity, etc. Bridge rectifier can be broadly classified into two single and three phase rectifier based on the types of input they works on. These types includes their further classification which can be made into both the single and three phase rectifier. The further classification is based on the switching device, the rectifier used, and the types are uncontrolled, half control, and full control rectifier. Some of the types of rectifier are discussed below. Let us look. Based on the types of rectification circuit, thus the rectifiers are classified into two categories: half-wave rectifier and full-wave rectifier. Half-wave rectifier only convert half of the AC wave into DC signal, whereas full-wave rectifier convert complete AC signal into DC. Bridge rectifier is the most commonly used rectifier in electronics, and the report will deals with the working and making one simple bridge rectifier circuit is the most popular method for full wave rectifier. We will discuss both the controlled and uncontrolled rectifier in detail with diagram and operation as follows. Uncontrolled rectifier. The types of rectifier whose output voltage cannot be controlled is called uncontrolled rectifier. A rectifier uses switches to work. The switches can be of various types: broadly controllable switches, uncontrollable switches. A diode is unidirectional device that allows the current flow in only one direction. The working of a diode is not controlled as it will conduct as long as it is forward biased. With a configuration of diode in any given rectifier, the rectifier is not fully in the operational control So these type of rectifier are called uncontrolled rectifier. It does not allows the power to vary depending on the load requirement. So this type of rectifier is commonly used in constant or fixed power supplies. Uncontrolled rectifier use only diode and they give a fixed output voltage depending only on AC input. Types of uncontrolled rectifier: half-wave rectifier and full-wave rectifier. Half-wave rectifier: a type of rectifier that converts only half circuit of alternating current into direct current is known as half-wave rectifier. Positive half-wave rectifier: a half-wave rectifier that converts only the positive half cycle and blocks the negative half cycle. Let's look at this diagram. Input of AC fuel cycle, DC output position half cycle. A negative half-wave rectifier converts only the negative half cycle of AC into DC. In all types of rectifier, half-wave rectifier is the simplest of them all. It composed of only a single diode. This is a diode and this is the AC source which is converting to half-wave rectifier. During the position of half cycle, the diode terminal anode will become positive and the cathode will become negative as forward bias. It will allow the positive circuit to flow through diode of AC and this is flowing in the opposite direction again. Full-wave rectifier. The full-wave rectifier convert both positive and negative half cycle of AC to DC. It provides double output voltage compared to the half-wave rectifier. The full-wave rectifier is made up of more than one diode. There are two types of full-wave rectifier: bridge rectifier, center tap rectifier. Bridge rectifier. Bridge rectifier use four diodes to convert both half cycle of input AC into DC output. In this type of rectifier, the diodes are connected in the specific form as given below. See, the AC source of current is flowing to D1 and it is coming to D4 and movement continuously going. During input position half cycle, the diode D1 and D2 become forward bias, while D3 and D4 become reverse bias. Here you can see D4, 3 and D4 become reverse bias and D1 and D2 become forward bias. Provide output voltage across the load resistor. During the negative half cycle, the diode D3 and D4 become forward bias, while D1 and D2 become reverse bias. In negative, it will be reverse opposite of positive half cycle. Working of bridge rectifier. Now, the circuit diagram is the parent that the diodes are connected in a particular fashion. The unique arrangement given the convert is made in bridge rectifier. Voltage that is given, the input can be from any source. It can be form of a transformer that is used to step up or down the voltage, or it can be from the mains of our domestic power supply. In this article, we are using 606 center tap transformer for providing AC voltage. In the first phase of the working of the rectifier during the positive half cycle, diode D3 and D2 get forward biased and conduct. Diodes D1 and D4 get reverse biased and do not conduct in this half cycle, acting as open switch. Thus, we get a positive half cycle at the output. Conversely, in negative half-cycle, diode D1 and D4 get forward bias and start conducting, whereas diode D3, D2 get reverse bias, do not conduct in this half-cycle. A central tap transformer is a dual voltage transformer that has two input and three output terminals. It's connected to the center of the output coil and which act as a reference growth. The T1 terms produce positive voltage and T3 term produce negative voltage with respect to T2. During the input position half cycle, T1 will produce positive and T2 will produce negative voltage. The diode D1 will become forward bias and diode D2 will become reverse bias. This makes a closed path from T1 to T2 through the load resistance below. Thanking you for watching this.